Yes. Oh, I will work till the day before the baby is born. Not because I want to, but because I am too poor to take any additional time off. So most of my maternity leave is very sadly already unpaid. So can't take any little extra time to myself. All right. Sure. Come in. Will you come and get it? You just look at you. You walk so fast. Your body isn't breaking apart. The little baby ripping it to shreds. All right. Okay, listen. We're reviewing today. Okay, and we're testing this week. So we need to be locked in. Okay? So your test covers two things. It covers the dy dx's. That's called implicit differentiation. So if you want to put it right here, okay, this is the d dx. Oh, you can't see it. Okay, d dx. And then related rates are the ddt's. So right here on question number 5, these are the ddt's. Okay? Okay, and then I'm realizing this says 1 and then section 4. There are no sections 2 and 3. It really should be just 1 and 2. Okay, because this covers two things, the dy dx's and the dy dt's. Okay? So let's do some examples together. Okay, the first question that we're going to do together is, which one? Let's do number 2. Okay. All right, so first question. Okay, we're locking in.
Everybody locked it.
Yes. Okay. What rule are you going to need to take the derivative?
Well, product
rule, yes. Okay, no quotient rule. Okay, that's okay. So d dx means we're taking the derivative with respect to x. Okay, and then we notice that we're going to need product rule on this term. Okay, so my u is going to be an x, my v is going to be a y squared. Then we're going to take the derivative of both of those parts. Now remember, if you're taking the derivative with respect to x, x gets special treatment. You don't have to do anything extra. It just gets to fly under the radar like a regular letter. Any other letter, you'll have to dy dx it. So what's the derivative of x? 1. What's the derivative of y squared? 2y dy dx. Very good. Okay, then from there, we're going to write our product rule, diagonal plus diagonal. Okay, then what is the derivative of 16 going to be on the other side? 0. Good. So we have a 1y squared plus an x 2y dy dx equal to a 0. Okay, who are we moving across to the other side of the equation? 1y squared. Why is that the term that's going to move? Because it doesn't have a dy dx. So I have 2xy dy dx. And it's a negative 1y squared. I'm not going to write the 1, but you can if you want. Okay, from there, we want our dy dx by itself. So we're going to divide the 2xy across. Okay, which means that my dy dx equation is negative y squared over 2xy. Okay? Now remember, that equation will tell you the slope at whatever point that you want. Yes, Alberto? Okay. Go down to part B. Okay, part B, asks you to find the point where x is 4. So I want you to put a little note that whenever you're talking about points or like ordered pairs, you need an x and a y. You're going to use the original equation to find x or y. Now they have to give you one of them. Okay, but if they give you one, you can find the other using the original equation. So write down xy squared is 16. And then we're going to plug in the digit that they gave us. They told me that my x is so I'm going to take my 4 from right here, plug it into that spot. So now we have 4y squared is 16. What do we do next? Divide the 4. That means that y squared is 4. And then next step. Which means that my y is plus or minus 2. Now, what that means is that you have 2 different points where your x is 4. So let's list both of them out. That means that my 4 could be with a 2, or it could be with a negative 2. Now, for delta math, a lot of times it makes you pick one. Okay, this question does the same thing by telling you that we have to be in the first quadrant. So if I want to be in quadrant 1, 1, 2, 3, 4, okay, which of those 2 ordered pairs would be in the first quadrant? This one, okay? But there are technically 2 points, okay? We just are going to choose one based on how they told us to pick. Okay, now from here, I want you to add an instruction because this is all over your test. And I don't want to do every example in the packet to be yapping up here the whole period. So I want you to put right tangent line. Okay, and we have practiced this a whole bunch. Okay, but there are questions like this in the other examples, and I want you to have a chance to remember how to do it. So what are the 2 ingredients that I need to write the equation of a tangent line? Point and a slope. Very good. I already have the point right here. So the other ingredient that I need is the slope. And remember, that's what the derivative is. So I'm going to put dy dx, vertical line 4, 2. And then I'm going to plug that ordered pair into my equation. So it's a negative y squared over a 2xy. So it's a negative 2 squared. Over a 2xy is a 2 times 4 times 2. Okay, how will the top come out? What number? Negative 4. Okay, and then question, will the negative go away when we square it? No, because you're squaring the 2, then you're applying the negative, right? Okay, on the bottom, 2 times 4 times 2. Okay, which is going to reduce to... Okay, yep, so we divide by 2, it'd be 2 over 8. Divide by 2 again, it'd be 1 over 4. Okay? So from there, you only need those 2 ingredients. So it's y blank equals blank x blank. And then remember that your x and your y are going to go in as opposites. Your dy dx goes in same sign. So my x is a 4, I'll put a minus 4. My y is a 2, I'll put a minus 2. And then this is negative a 4. Okay? All right, so you should be able to take a derivative, complete a point, find a slope, write an equation of a tangent line. Okay, let's go down to part C. The other thing you're asked to be able to do is to find d squared y dx squared. What does that mean? Second derivative, and I already took the derivative once, so I need to take it how many more times? Only one more time. Very good. So let's put, okay, take derivative again. Now, in order for me to take the derivative again, I want to make sure that my dy dx is as simple as it can be. Okay, I don't want anything in there that I could have crossed out but didn't. So will you look at your dy dx up here again? Is there anything that I could reduce in this to make it easier? The y's. If I have a y squared on top and a y on bottom, how many will stay? One where? Top. So I'm going to put here simplify. And that now is going to give me negative y over 2x. Now, technically, are both of those appropriate for the first derivative? Yes. But if I have to take the derivative again, this is going to be easier. Okay? So what rule am I going to need to take the derivative with that? Okay, very good. So I'm going to put needs quotient rule in part C. So the high is a negative y. Okay, and then the ho is a 2x. Okay, because we know it's negative y over 2x. So what is d high?
Negative y over.
Negative dy over dx. Okay, or you could put negative 1 dy dx. Okay, then for my 2x, what's the derivative? Just a 2. Okay, and then we're going to write our second derivative. So it's d squared y dx squared equal to, and then remember, it's ho d high minus high d ho over ho squared. You have it on a cheat sheet. Okay, so you shouldn't have to memorize it, but you should hopefully have it memorized. So I have a 2x times a negative dy dx. I'm going to write that like this. And then high d ho would be a negative y times 2. That would be a negative 2y. Ho squared on the bottom would be 2x squared. Okay. From there, let's minus a negative. We hate that. Let's make it a plus. Okay, and then we're ready to plug stuff in. Okay, because it says we're doing the second derivative for the point found in part B. So I want you to adjust your notation, put d squared y dx squared, vertical line 4, 2 equals. And then remember that when we did notes on this, we said you're really plugging in 3 things: the x, the y, and the answer you found for dy dx. So remember, I actually have to plug in a number into this spot. I already know what the number is. Okay, do we know what that number is going to be? Negative 1/4. Remember, we did it up here, that we found dy dx at that point, and we got a 1/4, so that's what's going to go in this spot. Okay? So it'll be negative 2. My x is a 4. My dy dx is negative a 1/4. Plus 2 times y is a 2. Over 2x squared would be 2 times 4 squared. Okay? All right, now for that first term, we have 2 negatives times together. So what's going to happen here? They'll cross out. They'll go positive. And then what about a 4 and a 4th? Yeah, those are basically just going to be a 1. So really, all I'm left with on that first term is a 1 times 2, which is 2. Plus 2 times 2 here is 4. 2 plus 4 is 6. Okay, and then on the bottom, follow PEMDAS. You're going to multiply that parentheses out first, then square it. So 2 times 4 is 8. What's 8 squared? 64. Okay. That will reduce. You can do it if you want to. It'd be 3 over 32. Okay. Questions on that? All right, now, if your test asks you to plug in a point, okay, you already know how to do it. We just did it. Okay, but if it asks you to write the second derivative, look at the way part D is phrased. It says, for any point, but in terms of x and y. The only difference is instead of you plugging in numbers to this whole thing, you're gonna leave it only x's and y's. So I want you to write d squared y dx squared. And then what is the only term in your second derivative equation that's not an x or a y already? Like looking at this. Obviously the 2's are fine. But what's the only other thing that's like letters, but it's not an x or a y? The dy dx. What you're going to do is just put the equation in that spot instead. So it'll be negative 2x. That's where my dy dx goes. Save it a spot. Plus 2y over 2x squared. But then I would say, wait, if I can only have x's and my y's in my equation, I'm going to put in the dy dx spot what the formula is for that equation. What is the simplified dy dx formula for the first derivative? Y over 2x.
Oh.
Correct. Okay. And then from there, we're going to notice a lot of stuff crosses out. First of all, the double negatives, just like they crossed out with the numbers. What else is going to cross out from that first term? We have a 2x and an over 2x. Those are gone. So this first term is really literally just a y plus 2y. And then what is y plus 2y? You're adding though 3y. And then on the bottom, 2x, when you square it, make sure you square them together. So 2x times 2x again, that would be 4x squared. Okay? So you should know how to find the second derivative 2 ways. The first way that you should be able to do it is with plugging in numbers. Okay, the second way would be to keep it x's and y's, but you'll have to drop your dy dx formula in. Okay? Questions on that? All right, we're only going to do one more of these guys. Let's do number 3. Turn the page. We're just going to do parts A and C together because we have to do A to do C. So will you take the derivative of number 3? Will you, yes or no, need any product rule or quotient rule? Which term is going to need product rule? Okay, and remember, it's the negative xy. You want to package the negative into the product rule. So this part here, we're going to need PR. Okay? So my u is a minus x. My v is a y. What does that make u prime? Negative 1. What does that make v prime? Very good. Okay, now don't go straight to your product rule because remember, you have to start at the beginning of the equation. So the first thing I have here is a y3. So what's the derivative of y to the 3? Okay, great. Perfect. 3y squared dy dx. And then when I get to my product rule term, it's diagonal plus diagonal. So it's a negative 1y. And then a negative x dy dx. Now, the derivative of 16, that's just going to go to 0. Okay, who are we pushing across to the other side? And if it used to be a negative 1y, now it's a... Okay, great. So I have a positive 1y. And then for the 2 terms staying on the left, they both have a dy dx. I'm going to GCF that out. So it'll be dy dx. I have the 3y squared minus x. Okay, then from there, what do we do with that parentheses? Divide it to the bottom. Very good. So your final answer for part A is going to be that fraction. Okay? So I'm going to rewrite it over here to the side nice and neat. So it'd be 1y over 3y squared minus x. Okay? Then hopefully in part B, you kind of get the gist. You'll find the rest of the point and then plug it in. You should also be able to write an equation for a tangent line, but if you need help with that, we can do some of that one-on-one when we're done doing examples together. Okay, go down to part C. Okay, part C says, find the value of x where the slope is undefined. Okay, how can I find an undefined slope? Okay, I'll give you choices. Do we set the top or the bottom equal to 0? Okay, so set the bottom equal to 0. Okay, remember that if you want an undefined slope, you want it to be a no, right? So here, let's write this over here to the side. Okay, no is an undefined slope. That's for a vertical. And then if it said horizontal, that would be okay where you have a 0 slope. Okay, so remember, you're either setting the top equal to 0 for a horizontal or the bottom equal to 0 for a vertical. So take the bottom of your dy dx equation, let it equal 0. What is the bottom of that equation? 3y squared minus x equals 0. Which letter would be easier to get by itself? The x. Very good. So I'm going to just plus my x across so that it's equal to a 3y squared. Okay, then remember, your game plan is to take that substitute and go back to the original equation and swap the x's out for 3y squareds. So my original equation, okay, I'm going to rewrite it here, was a y cubed minus xy equal to 16, and I'm going to plug it in for this x right here. So that way my equation's only y's I can actually solve. So I have y cubed. My x is now a 3y squared times y equal to a 16. What is 3y squared times y? 3y cubed. So I have a y cubed minus a 3y cubed. Can I combine like terms there? What is a 1y cubed? We know there's a 1 there, but maybe we didn't write it. Take away 3. Good. And then just keep solving. So after I combine like terms, 1 take away 3 is a -2. How do I get rid of the -2? Divide it. So I'd have y cubed is -8. Cube root. And when you cubic root, can you do negatives? Yes. Remember, square roots, no, they'd be imaginary, but cubic roots, you're fine. So my answer would be y equals -2. Is there an answer that says that? Does it say y? It's a trick. Don't pick it. So remember that if my y is a -2, they're wanting an x, then I'll go back to this little shorthand right here, and I'll plug it in right here. So I know my y needs to be a -2, then my x needs to be a 3 times -2 squared. So -2 squared would be 4 times 3 would be 12. Okay, remember that the negative is going to cross out when you square it. So D would be the correct answer there. Okay? All right, can you do it? All right, we're going to do a little bit off the next thing, and then y'all will have some time to work. Okay, first one that we're going to do is number 7, please.
Number 7?
Yes. Yes, the paper towels. Okay, so it says, suppose a roll of paper towels is 20 centimeters tall, and the paper towels are being unrolled. so that the radius is changing at a rate of 2 centimeters per second. Find the rate of change in lateral surface area of the roll of paper towels at the instant when the radius is 4. Then they give you the equation and this little hint that we'll talk about later. So set up find, given, when, and then we'll do equation right here. Okay, now guys, I know that these are hard, okay, but we've been doing them for a couple class periods, so let's see if we can kind of start getting the hang of it. So the first thing that I'm looking at, okay, is that it tells me how fast the radius is changing. How fast is the radius changing? At a rate of 2. So put dr dt is 2. Okay, then it says, find the rate of change in lateral surface area. So I'm going to find dA dt for surface area. Okay, now the equation that they gave us has an S. I don't want to use an S because then my S's look like 5s and no one knows what I'm talking about. So where the equation is right here, I'm going to switch that to an A, okay, for surface area. So it's 2 pi RH. 2 pi R. Okay. Then my when, did it give me a when? When? Says when the radius of the paper towels is 4. Correct. Okay, so we're going to draw a quick little picture, and here's why. If I take the derivative of this right now, I need product rule, because what two variables am I multiplying? 2 pi r times h. That's product rule. Let's think about if we need to do that. So draw yourself a little paper towel roll here, okay? There it is. And we're going to unravel, okay, the paper towels. Wow, I think. Now, if I pull the paper towels and I'm peeling them away, is my radius going to be changing? Actually, I see you're drawing beautiful pictures, so I'll give you a sec. Okay, but think about, as I pull the paper towels off the roll, is the radius of the roll going to be shrinking? Yes. Will the height of the roll also be shrinking? No. Even after you rip every paper towel off, the core is still the same height. So I want you to put that on this roll, okay, the height it says is 20, okay, but that's not a variable. That's literally how tall it is. So in this equation, we're going to sub the h in as a 20 because it's not a variable. It's always 20, whether I've pulled all the paper towels off or I haven't pulled any off. So I'm going to modify my equation and say, okay, well then my a is really 2 pi r times 20, which is the same as what? 40 pi r. Now, why is that version of the derivative better? Because now I don't need product rule. Okay, if I had a radius and a height that were both variables, I would have had to do a u and a v breakdown on it. But because this is not a variable, okay, I can treat it as a regular number. Okay. Then from there, let's take the derivative. What is the derivative of a going to be called? dA dt. Very good, because we're taking the derivative with respect to time. 40 pi r, what's the derivative? Yeah, think about like your r has a 1 on it. So 1 times 40 pi is 40 pi. And then my r would drop off because it was already only a regular r. So once you reduce it, it's gone. What do I have to still attach? dr dt. Now let's plug our numbers in. We know that our dA dt is going to be 40 pi times dr dt. But what's my dr dt? 2. Okay, then 2 times 40 pi would be what? 80 pi. Okay, now, unfortunately, this really doesn't make sense. So let's think about this for a second. As I pull the paper towels off, this says my area is growing at 80 pi square centimeters per second. Does that make sense that it's growing? So what should we have put on our 2 here?
Negative.
A negative, because what's happening to the radius as I peel the paper towels away? Shrinking. So it really should be a -2 here, which means a minus here, which means minus 80 pi would have been correct. Okay? All right. Questions on that? All right, we're going to do one more. Turn to number 9. Okay, on the back with the little star on it. All right, last one. Okay, it says we have a railroad track and a road crossing at right angles. Okay, let's draw a little picture. Okay, number 9. Then it says an observer stands on the road 70 meters south of the crossing. So if you want to give yourself a little compass here, north, south, east, west. Okay, where is the observer, the guy? 70 meters which way?
South.
So here he is. Okay, then it says he watches a train traveling 60 meters per second. Okay, then it says how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection. So when you draw your train, it's headed east, but it's already gone through the tracks. So it's over here. Okay, there it is. And it's going this way. All right, now the most important part of you setting up your question is you have to know what's changing, what's not changing. So first question, let's draw our little triangle here. Is the train moving?
Yes.
Yes, then we have to give it a letter. So I'm going to call it X because it's kind of flat. Okay, but the train is X. What about the guy? Is he moving?
No.
Yeah. So how far away is he? He's 70, right? But he's not moving. He's just standing there watching the train. So if it's not changing, we're just going to give it a 70. Okay, then from there, the third side, it's going to be how far apart the train is from the guy. And I'm going to call that, we'll do D for distance. Okay, now set up your find, given, when. And I want you to just label what you can. Okay? So find, given, when. And then we'll do the rest of it together, but read through it real quick. Okay, we want to know how fast the train is moving away from the guy. What letter did we pick for that? X or D? D, because D is how far away the train is from the guy, right? So we're finding DDDT. But we're given how fast the train is moving. How fast is it going? Okay, so we're going to put that dx dt is 60. Now, think about if it's positive or negative. If the train already went through the intersection, what's happening to this distance? Is it growing or shrinking? Growing. So 60 positive is appropriate. Okay, then for my when, it says 4 seconds after it passes through. I'm just going to put 4 seconds later. with a question mark. Okay, and we'll do that in a second. Okay, what equation relates the three sides of a right triangle? A squared plus B squared equals C squared, but in ours, it's an X, a 7D, and a D, right? So do X squared plus 7D squared equals D squared. Okay, so Pythagorean theorem is going to be your relationship between the three sides of a triangle. Then take your derivative. 7D squared goes to what? Constant, so it goes to, what? Oh, but it's a constant, no letter with it, right? So 0. Okay, what about the X squared? 2X what? Good. Okay, then on my D squared. Very good. Okay, and then when I go to plug stuff in, I notice, okay, that I don't have the X or the D to go into my equation. So we're gonna have to go back and find those. Let's talk about these 4 seconds. Okay, because the next step usually is to plug in, but I notice I'm missing some information. So how fast is the train going? 60 per second, and I'm gonna wait 4 seconds. So 60 meters per second, and I'm gonna wait 4 seconds. How do I know how far the train goes? 60 times 4, very good. How far would the train go? 60 times 4 is 240. Okay, that's okay. So 60 per second for 4 seconds would be 60 times 4, which is 240 is how far the train is going to go. Now, quick question. If the train is going to travel 240 and this is 70, can we find this? How? Pythagorean theorem. So I forgot to make you get a calculator. Will you go get one? Maybe get one for a friend while you're up. Okay, but we're going to need to know how long this side is and do Pythagorean theorem on it. You're going to need it for the review anyway. I don't know. I'll have to look at the numbers. I don't think any of them are this big.
Okay. So I won't got it.
Nope, we just finished the notes you already had. Okay, so once you have your calculator, you know these two sides, find this side. So a little a squared plus b squared equals c squared, and it should be a whole number. What'd you get? Okay, that's correct. So once you get that third side, I want you to plug in and then solve it. Okay, look at your answer choices, see which one's right. And then can I just go pee really quick?
Okay.
While you do it, so find, you already know X, find D, then plug it in. Okay, you can do it. The only way I would say no to that is if the numbers are small enough. I think I'll have to look at it. Okay, but find it, do it, okay? It's wrong person.
How do you find it?
My phone uses it. So I don't know. I suppose.
You don't know the math.
What's the answer to Oh, sorry, I didn't. So you put 2, then for X.
And then you can do for the mountain into the you put to the times 6 of E because E equals to E. Where did you get to? What you do that control? What you do is access E equals to square. That's E equals to you access to E to 6.
So you lost me, I don't know where it was.
I got no letters. I got that. People who find I know. I decided that's the job of the business. Oh no, he's going to get it. Look, you're not. They plug it into the
Okay, let's go step by step. I don't know. How did you do this thing?
Why do you have like? Why do you have
Okay, plug in the number next time.
Why do we have a pen? Okay, so it's 70 squared plus 240 squared plus C squared.
Oh, you plugged it into it already. Yeah.
What's fine? How did you get to?
I think I got it. Me, I know I am.
And then you
But I
divide by
know.
Bro,
I have 2 or something.
did y'all find D?
Yes.
How do you find D? I literally
I don't
was
see
going
me
to
back. It's gonna be bad.
Huh?
Yeah, you're really bad. I don't even sign up for the AP.
I already did it. I'm not taking next question. Wait, how do you get oh wait, I know how to do it. Oh, I know how to do it. Okay, 70 squared. 2 squared squared.
You see, I was focused on the about it.
And then you're gonna square root it. It's 250. I didn't know. Okay, what's that? And then you plug it in. Oh.
Okay, wait, what's that?
This apple too.
Now.
Oblique. You know, like it's like are you mad? Actually, you know, there's don't do that. What's
I got the answer.
You got it?
Yes, we
Wait, what's DD?
I think it's A, isn't it? Yes, good.
Oh no, what is that?
So you should have gotten 250 for this guy, yeah?
Wait, don't say anything. Let me solve it first.
What?
I know it. I know it.
Okay, I will silently write it without distracting you.
Okay. I'm so smart. Oh my god, I'm so smart.
Oh, I didn't get it.
I don't tell you it's kind of 57.6 boy.
Yes, good.
I'm good.
So it'd be 2 times 240 times 60. That number is equal to 2 times 250 is 500 DDT. And then you divide, yeah? Y'all good with that?
Yeah.
So this divide by this is 57.6. Okay? All right, let's do part B. Okay, so it says, at how many radians per second is the angle the man is watching the train from changing at the same instance as part A? So for part B, I want you to draw a theta into your picture. We did one of these last time. Okay, where theta is the angle that the guy is facing as he watches the train go by. So theta is the angle for his line of sight. Okay, now I want you to label from last time the opposite, adjacent, and hypotenuse on your triangle. So if this is my theta, the guy's head as it turns watching the train, which side is the hypotenuse? Okay, hypotenuse. Which one is the adjacent?
The 70.
Okay. And that makes X the opposite. Okay. All right, so in part B, if you are asked to find, all right, remember we're locked in. If we're asked to find an angle, you have to use SO, CA, or TOA. So let me give you a hint. I think we talked about this with the fish problem. Okay, but if a side is not changing, you definitely want that side. So which side do we definitely want to include? 70. So I'm going to write down SO, CA, and TOA. Okay, now listen. We really want 70 in our equation. Which equation does not have the adjacent side in it?
Whoa.
We're not picking SO. Okay, because we really want to have a number that's not changing. That's better. Okay, then out of the two that are left, I could do CA or TOA. Okay, which dx dt or d dt is a nice, easy whole number? Okay, I would probably, if it were me, pick TOA, and here's why. Okay, if I do the opposite, it's the letter X, and the dx dt was a nice, easy 60. Versus if I do CA, and I have the H in it, my d dt was kind of ugly, right? It was 57.6. Now, does it matter which one you pick? No, just pick one. Okay, so we're going to pick TOA. So write down for your equation, tan theta equals opposite over hypotenuse. My opposite side, oh wait, hold on. Opposite over adjacent, I misspoke. So my opposite side is an X, my adjacent side is a 70. Now, could you also have done this question with cosine? Yes, and if you want me to walk through it with you later, you get the same answer at the end anyways. Okay, what is the derivative of tan theta? Secant squared theta d theta dt. Okay, then on the X over 70, that kind of looks like quotient rule, and we hate quotient rule. So if we can avoid it, let's do a rewrite. Okay, for this side, I'm going to rewrite this as 1 over 70x. Because that's the same thing. Really, the 70 is in the front, and it's just a regular x. So what's the derivative of 1 over 70x? 1 over 70. And then what would I have to attach to it? D? Not dd. dx dt. Okay, then from there, I'm ready to plug stuff in. And I already know what dx dt is. What is it? How fast the train is going? 60. So this is going to be 1 over 70 times 60. And then for my secant, I'm going to have to plug in the sides of my triangle. Does anyone remember from when we did these notes? Secant is which one flipped? Secant is cosine flipped. Very good. Okay, and remember, this is all on your hand trig cheat sheet. So if cosine is usually a over h, what is secant? H over a. Very good. So look at your little thing. I'm going to use h over a for secant. And when I say h over a, that's hypotenuse over adjacent on the triangle. How long is the hypotenuse? 250. How long is the adjacent? 70. And then that is squared times a d theta dt. Okay? From there, we want to get our d theta dt by itself. So let's just solve what we have so far. In your calculator, do 250 over 70 and then square it. Okay, do it as a pretty fraction. So I'm going to do 250 over 70 times 250 over 70 again. Okay? So 250 over 70 times itself is, I got it as a fraction. If you have it as a decimal, that's fine. Okay, but I got 625 over 49. D theta dt equals. And then on the other side, what's 1 over 70 times 60? And mine is coming out as a 6, 7. Okay, but you could have it as a decimal. And then how do I cancel out this fraction? Okay, how do I cancel out this fraction to solve?
You times it
By the
49.
49 over. Okay, Okay, to get rid of a fraction, you multiply by the reciprocal on both sides. So if I'm trying to get rid of a 625 over 49, I would multiply the other side by a 49 over 625. Okay, then do that in your calculator. So 6 over 7 times 49 over 625. Okay, gives me 42 over 625, and then I'm going to have to divide that to get a decimal, 0.067. What a great question. Okay, I actually made it up years ago, so this wasn't even crafted to have so many 6, 7s in it. Okay.
Wait, I gotta take a picture again. Oh my god.
Take a picture with what?
This is
Not a yonder device, surely. Okay, so last thing I'll tell you, there's only one more of these on here that's an angle. I'm not going to do it with you right now, but it's number 8, part B. Okay? Are we all done?
Yeah.
With the whole thing?
Yeah.
Oh, okay, great. Thanks. Okay, so now you're finishing the review, yes?
Yes, ma'am.
Okay, you have 30 minutes, a little bit more than that. 30. I know, truly. Probably.